Okay, so this workshop's going to go over how to write a factored form equation given roots or our zeros or our x-intercepts, whatever you want to call them. So our problem says, suppose there's a quadratic function that has roots at x equals 1/3 and x equals -1, and the function opens downward. Write the equation for the quadratic in factored form. So automatically, I know it's an equation, so I'm going to have y equals, and I'm actually going to look at this x equals -1 first because that's pretty easy to handle. If I am at -1 and I'm trying to get to 0, I need to add 1. So my factor that represents x equals -1 is x plus 1, because if x is -1 and I want to make my parentheses 0, I'm going to have to add 1 to that. Now I have a root that's a fraction, so we're just going to go through how to make this into a factor that we can use easily for our quadratic factored form equation. So if I have x equals 1/3, I'm going to go ahead and write that. Go ahead and take notes with me. X equals 1/3. And I know that my next step is to get rid of the denominators by cross multiplying. So I'm going to go ahead and put x over 1, cross multiply. I get 3x equals 1. And then I need to make the right side of my equation equal 0. And in order to do that, I'm going to have to subtract 1 from both sides. So I'm going to bring my work up here. I get 3x minus 1 equals 0. So now I have my usable factor here, 3x minus 1. And I'm going to go ahead and plug that into my equation, 3x minus 1. And then this is my factored form equation. There's one more thing that I need to add. If I graph this in Desmos, and I'll go ahead and do that, y equals x plus 1. I get a parabola, which is perfect, but my problem is asking for my function to open downward. So the only thing I need to do is add a negative sign so that I can flip it and to make my parabola open downward. I'm going to go ahead and put that here. This is our final factored form equation for our quadratic given our two roots.